Now we will see how to perform mesh analysis. For that I am taking one example circuit. So voltage source V1 with resistor R1 in series. Then two resistors and voltage source V2 I am taking, or V3 with series with one resistor. Then the negative terminals of the two voltage sources are grounded, and here I am giving one more resistor, here another resistor. So I am dealing with three meshes actually. Okay, so it is node 1, node 2, node 3. Resistors are R22, R12, this is R11, this is R33, R23, and this is R13. Okay, this is a circuit I need to perform mesh analysis. So performing the mesh analysis means finding mesh currents only. Finding mesh currents is nothing but performing the mesh analysis. Okay. Then finding node voltages means performing nodal analysis. Okay, so in the nodal analysis we are finding the node voltages. In the mesh analysis we are finding the mesh currents. So just we will assign the mesh currents. Mesh 1 current is I1, it is mesh 2 current is I2, it is mesh 3 current is I3. Okay, so it is mesh 1, mesh 2, it is mesh 3. So we'll write KVL, okay, in mesh 1. Okay, then what will happen will, so how to write means, for simplicity I am telling one thumb rule, that is sum of voltage drops is equal to sum of voltage rises. So in the mesh 1 we have three resistors, R11, R12 and R23, R11, R12, R23, and only one voltage source is there, that is V1. So across R11, R12 and R22 you will be having the voltage drops, and the voltage rise is there in the clockwise direction. If you observe, there is a voltage rise by using V1. Okay, then already we know about what is the mesh current and what is the branch current. If the element or if the branch is only related to only one mesh, then branch current is equal to mesh current. That means through R11, what is the current? I1 only. But through R12, the current is I1 minus I3 because it is related to mesh 1 and 3. And through R22, the current is I1 minus I2. Okay, current you know, resistance value you know, multiply those two as per Ohm's law, you will get the voltage drop. Okay, that is what I am going to write now. So some of the voltage drops, you no need to mention minus also. Okay, because we are taking just a drop only. Okay, otherwise because it is first time, I will write completely. So through, I'm starting with the V1 otherwise. So we will take, you can follow this one, or simply all the voltages we will take in the loop 1, that means in mesh 1, will make that is equal to 0. Algebraic sum of all voltage drops in a loop is equal to 0 as per KVL exact definition I am applying. So you can take or ending symbol I am taking. Already I1 I have taken in the clockwise direction, ending symbol I am taking, so that the ending symbol for the V1 is plus only. Current is going like this, so entering it minus and leaving it plus. So ending symbol is plus. But for the passive elements, like resistors, current is enters at a positive and leaving at a negative. For this one, I1 is entering at positive, and I1 is leaving it negative. For this R22, I1 is entering at positive, I1 is ending at a negative. But what is the current in R22 means not just I1. Okay, current in R22 is I1 minus I2. current in R12 is I1 minus I3 because that is related to 1 and 3 meshes. But what is the current in R11? Only I1. Current in V1 is only I1. Now you can able to write the exact KVL expression. That is, I am using the definition now. Sum of all the algebraic voltage drops in a loop is equal to 0. So plus V1 minus I1 into R11 minus what is the current in R12? I1 minus I3 into R12 minus what is the current related to R22? I1 minus I3 into R22. I have completed all the elements available in the loop 1, that means mesh 1, it is equal to 0. Now you can send all the terms except this V1 to the right side, then you will get I1 R11 plus I1 minus I3 into R12 plus I1 minus I3 into R22 is equal to V1. This is what I can write directly by using this definition. Sum of voltage drops is equal to sum of voltage rises in the mesh form. Okay, so across the resistors we will be having the drops only. So you can get all the voltages related to all the resistors, that is equal to voltage rise is due to in this independent voltage source, so that is V1. Okay, so it is equation 1, but further I am going to change this one. I will write some of the resistors into I1, some of the resistors into I2, some of the resistors into I3. So what I will get, R11 plus R12 plus R22, this entire resistance is multiplied with I1. Then what about I2? Then R12. R12 is coming. It is actually I2, not I1. So what I will get? Minus R12 into I2, then minus R22 into I3 is equal to plus V1. Now I will take this is equation 1. Now apply KVL at mesh 2. In mesh 2, if you apply, I'm applying the same definition, that is sum of voltage drops is equal to sum of voltage rises. Okay, I need to go in the clockwise direction. Then first you tell what is the current related to R33, just I2, because it is related to mesh 2 alone. Next, what is the current related to R22? It is I2 minus I1. We are working in mesh 2 now. So current is I2 minus I1. Next, what is the current related to R23? It is I2 minus I3. I2 minus I3 we have to tell. So some of the voltage drops I'm taking now, R33 into I3, and then R22 I'm taking. So R22 into I2 minus I1 plus another resistor is R23. So R23 into I2 minus I3 is equal to, do you have voltage rise or voltage drop? In clockwise direction, here plus minus V3 is there. So here it is reduced. Okay, that means it is drop. But to follow this expression, I need to write it is equal to voltage rise. V3 is actually falling. To make it rise, I have to take minus V3. Okay. Otherwise, if you get any confusion, simply you take the equation like this, how we have written in the beginning. Okay, in the mesh one, how I have written in the beginning, all the sum of all the voltage drops in a loop is equal to 0. That is what you can able to apply. Now we'll do take common I1, I2, I3, any common things are there, that I will write minus R22 into I1 and R22 and it is R23. So R33 current is I2. I have taken here I3. So plus R33 into I2. Okay. What about I1 is over, I2 is over, I3 is here. minus R23 into I3 is equal to minus V3. This is equation 2. Similarly, you can write KVL in mesh 3. Okay, in mesh 3, R13 is related to only mesh 3. So R13 into I3. Then R23 is related to 2 and 3. So plus R23 is related to 2 and 3. Its mesh current will become, its branch current will become I3 minus I2. Then R12 is also there. So R12 into I3 minus I1. There is no voltage rise or voltage fall by the independent voltage source, because in mesh 3 there is no independent voltage source. So its summation is equal to 0. Now I1 terms only one is there, minus R12 into I1. I2 is related to only one time, that is minus R23 into I2, plus I3 is related to 3 times R13 plus R23 plus R12 into I3 is equal to 0. This is equation 3. Okay, now these 3 equations we have to solve. That's it. So, but I can write all these equations without using this much bigger process. I can able to write all these 3 equations very easily by observing the diagram, given circuit diagram. Now you see carefully. Those 3 equations I am going to write now. Okay, directly. So apply mesh 1, you see. Mesh 1. So mesh 1 current is I1. So what are the resistances involved in the mesh 1? R11, R12, R22. R11 plus R12 plus R22 multiplied with I1. That's it, simply. Next, what is the resistor which is common to mesh 1 and mesh 2? R22. So take minus R22 into I2. What is the resistance common to mesh 1 and mesh 3? That is R12. So minus R12 into I3 is equal to, do you have any voltage rise? Yes, that is V1. Equation 1 is over. Now mesh 2. Okay, so with respect to I1, if you want to think, what is the resistance common to mesh 2 and mesh 1? That is R22. So minus R22 into I1. Now all the resistances, sum of all the resistances available in mesh 2, you have to take. That is R22 plus R23 plus R33 multiplied with I2. Okay, plus the resistance which is common to mesh 1 and mesh 3 is R23. So because it is a sharing resistor, I have to take minus R23 into I3. Okay, it is equal to, do you have voltage rise or fall? Fall is there by the independent voltage source. So I need to make it rise for that minus V3. Now mesh 3. Okay, in the mesh 3, first with respect to I1, if you want to talk, R12 resistor is common to both 1 and 3. So minus R12 into I1. Next, what is common to 2 and 3? What is common to 2 and 3? R23. So minus R23 into I2. Now all the resistors which are available in the mesh 3, directly mesh 3, are R12 plus R23 plus R13 multiplied with I3, okay, is equal to 0. Now 3 equations we can write directly. By observing the diagram itself, we have written 3 equations directly, and these 3 equations by the application of the KVL also we got previously. These equations 1 to 3 are similar to these 3, are same as these 3 equations only. Now we need to solve these. Okay, already I told in the mesh analysis we are solving for the mesh currents. Okay, so now these 3 equations we can write in the matrix form also very easily. So diagonal elements are actually some of the resistances which are involved in the mesh 1, mesh 2, and mesh 3. Okay, then non-diagonal elements, how to write this one? It is actually equation for mesh 1 KVL, it is mesh 2 KVL, ఇది mesh 3 KVL. Okay. So with respect to I1 is over. Now here you have to write with respect to I2. Means minus R22 into I2. Okay. And nothing is related to, sorry, 1 and 3 are also related by R12. So minus R1. If anything is sharing, we have to keep minus. Okay. Then 2 and 1. Again here you will get minus R22. And here 2 and 3, that is minus R23. Okay. Then 1 and 3, that is minus R12. Okay. 2 and 3, that is minus R23. Then here you will get I1, I2, I3. It is equal to, you got here V1 minus V2, 0. These are 3 equations we will get now. Okay. So it is looking like here it's the resistance matrix, and here current vector is equal to voltage vector. You need currents, mesh currents, that is equal to inverse of resistance matrix multiplied with this voltage vector matrix you have to take. So how many meshes you have? Number of meshes 3. Okay. Number of mesh currents are 3. Okay. What is the size of the resistance matrix? 3 by 3. So if you have number of meshes 3, mesh currents are 3, and size of the resistance matrix is also 3 by 3. This is the way of solving the circuit using the mesh analysis.